All right. So just moving from the device integration, we are now moving to authentication and authorization. So before we move on to how do we authenticate and authorize the IoT devices, please let me know what do you mean by authentication in general, which everybody does in their day-to-day tasks. What is the difference between authentication and authorization?
Authenticating is checking whether the credentials are right, and
Yes, right. Credentials, user credentials uh, are valid or not. Okay. What is authorization then?
So allowing permission, read or write permission to certain individuals.
So individuals who are what type of access is going to be given to the individuals? Whether they have to read or they can write, they can update, they can delete or not. So those access privileges, the access rights. So those basically, I hope everybody knows what is authentication and authorization. So please remember, those who are not aware of what is authentication and authorization in IT terminology or in our information technology, computer science. So whatever you are now doing, the login attempts, whenever you try to browse something on the computer, so usually you switch on your computer and you provide your username and the password. So that is your login prompt is going to come. So basically that login process is nothing but authentication. It is whether you are an authenticated user to use that particular laptop or not. So that authentication, user authentication do takes place, and the operating system checks whether the user is the right person to use that system or not. That is basically authentication. Now, coming to authorization, usually when you access certain resources, maybe some files or some other hard disk or some other devices which are connected to your laptop. So sometimes you may have some privileges. Only privileges means you are authorized to do some only, not all of them. Like sometimes just reading the data from a file or writing the data to a file or reading and writing, updating, keep on like this. So there are different aspects of authorizations. But when you come to Internet of Things, how this authentication and authorization security mechanisms are being performed and have been carried out for various IoT applications. That is the most crucial parts. So here, of course, I'm not going to read each and every line, but let me just explain to you. So the notes anyway, I'll put it on the course page, Moodle course page. Then you can see this one. So authentication, please remember, as far as the IoT, this the material is related to IoT only. It's not in general authentication and authorization. Make a note of that. So authentication is the process of device identification. A particular IoT device is a valid device or not. A valid device in the sense the device which is to be sending or receiving data from the sensor device or not, either to the gateway or to any application or not. So that is what authentication basically is, the process of device identification, while authorization provides permissions. So permissions for a device, what the device has to do, whether it has to just simply read it, or it has to forward it, or it has to update it, or it has to do some processing, something or the permissions that are been ascertained to that device. So that is basically your authorization. So IoT devices uses these two processes. Please remember authentication and authorization. Most of the literature, most of the books, or sometimes even when you hear from some lecture notes or some other speeches, usually the speakers, the authors, they interchangeably use this authentication and authorization. But please remember, there is a difference between authentication and authorization. Don't use it as you like it or as you understand it. So you please make a clarity for yourself, have some clarity. Whenever you use these two words, they are meant to have certain purpose. So now let us understand how this authentication has to be is being given to the IoT system when you deploy it for certain applications. Applications means anything, whether it is a smart home, whether it is body area networks or something like human activities that are being monitored in a smart home, or it in smart agriculture, or it can be smart transportation, any kind of application where you deploy some IoT devices and you try to monitor the environment or to the physical phenomenon of this environment. When you try to collect some data, so the devices has to be properly secured for your data transmission to take place in a better way. So that is the point of to understand how this authentication and authorization do takes place for an IoT devices. So authentications and authorization, please remember, it is not as a standardized procedure that they have classified, but more or less many of the applications do follow certain three types of authentication and authorization models. So basically, those three types we can understand like this. So when can you please recollect when you are sending the data using MQTT protocol, what exactly has happened? Can you please anybody tell me when you are sending the data from your sensor device to your Raspberry Pi, where Raspberry Pi is your gateway? So what MQTT protocol has done? Can you please recollect that particular step so that it will be easy for us? Can you please tell me what is the MQTT command you have used? Hello, am I audible to you?
Yes, sir.
What is the MQTT command that we have executed for sending the data from the while publishing the data, or for your while you are going to subscribe the data from your ThinkSpeak? So what is the command that you have used? Can you please recollect the command?
Publish dot sing empty publish dot single command.
Publish dot single, yeah. So if you remember in that command, whether you have implemented or not, whether you have tested or not, you might have typed -u and -p also sometimes. So what is that -u and -p? Basically, -u is user and the user's corresponding password. So the
Yes.
command, yes, please. Yeah, the command that you type is basically a one-way command. One-way means you are from the you are from the publisher, from the sensor device, you are sending the data to the gateway. That is for your data to be accessed to the other side world. So that particular publishing command, you when you typed it, you might have put some little bit of authentication process there by giving the username and the password, so that username and password only can be used to send and receive the data or publish and subscribe the data. So that is one way of one way. That is just one way. In one direction, you are doing certain kind of authentication. Now there is another way, the second method. So the second method is basically the mutual authentication. So what is mutual authentication? Mutual means the sender and the receiver both tries to have some kind of handshaking. Handshaking means both tries to have some kind of understanding between each other, how the data has to be shared among those client and server, or between two devices, or between the IoT devices where those IoT devices are connected to the gateway. So the gateway and as well as the sender both do have certain kind of handshaking mechanism. So we usually call it as a mutual authentication. So that is a mutual authentication. That is basically a two-way authentication. Now there is another third way, or another third method of authentication. Basically, these authentications and authorizations, if you look into the computer networks, or in general the IoT systems, either they do perform with the help of distributed nature or in the form of centralized manner. So when you say distributed, it means the devices which are distributed and they are interconnected. So they try to have some kind of authentication mechanism. Either it can be one way or it can be two way. So it means the devices, when they are distributed with each other, they try to exchange the data by following certain protocols. That is the handshaking protocols. So either it can be one way or it can be both the ways, the sender and the receiver, or the two devices which are communicating with each other. So that is basically in the bigger picture, it is a distributed way of authentication. So the distributed way of authentication can be either it can be one way or it can be two way. So the two-way distributed authentication is basically, we call it as mutual authentication. So here the protocol used between the devices, they exchange the protocol mechanism for having the reliable transfer between those two devices. But the third one, which we call it as a centralized three-way authentication. That is the three-way means that the third way here. Please don't confuse between there are three different ways here. This is the third way. So what is the centralized means? Both the devices, the sender and the receiver, both the devices, they try to have certain handshaking mechanisms with another third person. That third person can be a server. So basically, a centralized server which keeps track of which devices can exchange by following their certificates, by following their signatures, by following certain public key infrastructures, PKI, public key means the cryptographic algorithms and the cryptographic signatures that needs to be followed. So the in the third method, that is the three-way authentication. The three-way authentication is basically the sender, the receiver, and the third person is basically a centralized server, where the centralized server will keep track of all the certificates. So whenever a sender and the receiver has to have certain transportation of data, usually the transportation of data is going to take place once the authentication is being performed by the server. Server, once it is validates the sender and the receiver, then only after the validation of the sender and the receiver by the server, then only the data transportation do takes place. So these are the three different ways, usually the authentication and the authorization, they do takes place. So one way is to have just the sender, by giving the user credentials, do send the data to the receiver. It means a device one, like your MQTT protocol which you have used, that is MQTT protocol is a good example for your one-way authentication mechanism, where you are specifying the user and the corresponding password to the gateway where the data is getting published by so and so, coming from the so and so user. So that is basically one-way handshaking mechanism. It is not a handshaking, one-way authentication, where the receiver just understands the data is coming from a authenticated user. So that is one way of handling the authentication and authorization when the devices do communicate with each other. And the second way is having a mutual authentication. The sender and the receiver, both the client and the server, in terms of computer networks. Similarly, in terms of IoT, both the devices, it can be sensor devices, the gateways and the sensing devices, both the devices do exchange the certifications or do exchange the handshaking protocols. Usually our transport layer service, TLS, and secure socket layers, SSLs, they will try to take care of that mutual authentication for exchange of data. So that is basically, that is another way. And the third way, basically the having a third person in between the sender and the receiver. In between the two devices, you are going to have one more entity. This is basically a server. So that server will have the authentication and authorization measures and the models related to the client and the server for both the devices. So both the devices, they do communicate with each other with the help of the server. When the server authenticates, then only these two people authenticate. Of course, if you try to follow all these different methods, either one way or two way or your three way, of course, a lot of computation is involved. And please remember, in IoT, we have a resource constrained computing devices. So the security mechanisms that you incorporate for your reliable data transfer between the devices. So if your security method itself is very long process, then of course the real-time data transmissions and of course the processing of the security measures for data transfers to take place will be very much difficult. That's why in the fourth unit, we are going to understand, study what are the different security cryptographic algorithms and secure mechanisms can be deployed for our different IoT devices. But at this point, you please have an understanding about the authentication and authorization of these devices. So this is the basic different types. So usually whenever we use the communication protocols like the MQTT protocol, what we have seen in the earlier stages, you can use those one-way single way or one-way authentication mechanism to transport the data from a device to your gateway. Similarly, you can use X.509 certificate, which provides security for certificates. Of course, whenever you incorporate this X.509 standards for our IoT devices, remember these X.509 certificate standards are meant for your websites, for your laptops, for your other resources. So for your web pages, of course, there you have good amount of RAM, good amount of CPU, and of course your communication capabilities, your bandwidth, and everything will be high. So, but how these secure mechanisms are going to be incorporated on the IoT is really a challenging task, and most of the applications do take place. So, how they are being implemented, we'll see one case study today. From this case study, we'll try to understand how the IoT devices do also support the authentication and authorization mechanisms. Of course, this notes, the running notes, you can get it from the course page. You can go through it, read it, and if you're having any difficulty in understanding or you're not understood, you can ask me through email or in the next class. So let me proceed to another example here. This is one particular paper. So am I audible to you?
Yes, sir.
Yeah, are you able to see this particular paper, Continuous Authentication and Authorization for the Internet of Things?
Yes, sir.
Are you able to view this paper? Of course, I'm going to discuss this paper now. Anyway, it is not a boring paper, don't worry. But it is very interesting paper, and new ideas can be come out, and I expect something at the end of the discussion. So please focus on listening to this particular discussion on this paper. So this is one paper which is published in IEEE Internet Computing. Of course, this Internet Computing is one of the magazine published in 2017. Of course, these are the authors, Mohammad Shahid and Muninder K. Singh from North Carolina State University. But okay, now let us understand what this particular paper is. So this paper uh, is all about how authentication and authorization can be uh, implemented on a some kind of a wearable device, and not only on the wearable device but on the ambient assisted living environment. So there are two different contexts, two different applications. One is on a wearable device. Wearable means you are going to wear it on your body. So most of the time your wearable devices means they are going to be made available on your body most of the time, and you use it for certain purposes. So on that particular devices, how your authentication and authorization is being deployed. And on the second case, on the second context, we'll see for an environment where certain devices, how they are going to get communicated with each other. And these authors, they have come out with a very interesting approach, which everybody can also do it at their home. You need not have specialized IoT devices. So that is what the one case study, use case study, they are given the experimentation details that we'll discuss. But the point of discussion is, please let me, you need to understand in a way that whenever you try to have certain authentication process, you require an user interface. Yes or no? Hello. Whenever
Yes.
you try to log into a computer system, whenever you log into a computer system, you require an user interface. You require a keyboard. You require that login user interface form, and you require a mouse. And once all these are available to you, then you try to enter your username and password. So you are entering your username and password with the help of the keyboard, mouse, and of course the user interface, that is the application developed, which will authenticate you to access the resource of the system or not. Usually, whenever you do this authentication, most likely you require user interfaces. Please remember, until unless you don't have a user interface, like enter the login name or the password or the other security mechanisms nowadays, they are being put on in for any application. Until unless a user interface is there, you will not be able to either enter into that application or enter into that system or access the resources or do whatever you like to have. So basically, you require an user interface. User interface, very simple to say, a login interface, a login prompt. Do you think that a user interface is possible for an IoT devices when you deploy it on a system? Whether because your IoT devices are very small, small in size, they don't have any screen also. You cannot see any screen on the Raspberry Pi sometimes, or not only Raspberry Pi or any sensing device. A user interface that okay, now this device can be used to send the data. Like that, you don't have any display unit, you don't have any screen, you don't have any a visible thing that you can and a visible or a user interface where you can enter some data and try to authenticate the device. So most likely for IoT devices, there won't be any authentication process, but authentication process not like what you enter into your computer system. It will not be like you login prompt, but there are other ways, other alternatives for IoT devices. So that's what the point of discussion here is. You can see the discussion here. What it says is, so when we are entering the era of Internet of Things, as computing devices become smaller, smarter, and ubiquitous, computing has become to embed into your environment, attaching the physical objects or things. So here, although IoT devices often have compute power close to those of conventional computing devices from a few years ago, one of the ways in which typical IoT devices differ is that they lack conventional user interfaces. Please remember, IoT devices differ with the conventional other typical devices in terms of conventional user interfaces in the form of keyboards, your mouse, and your touch screens. So IoT devices will not have your keyboards or your mouse or your touch screens to enter the username and the password. So that is the basic drawback. So if you see examples of computing devices such as Fitbit activity tracker or a suitable computing device such as Arduino LilyPad and a smart fabrics. So if you see these things, most of you might have seen a Fitbit. Basically, a Fitbit is like a watch, a smart watch, or most of the people when they go for walking or for jogging, they used to measure how much distance they walk or they jogged and how much calories were burned. Means basically your health parameters like your heart rate, your skin temperatures, all those things, they are wearable devices. So those are your Fitbits. They basically, that is also basically a small IoT device itself, because it has got its some sensors and other ingredients which are related to the IoT device. So these Fitbits, you might not see a very big screen to enter the username and a password. They don't have those things. So a smart fabrics, it means nowadays you can see those clothes where some sensors are already been embedded into the clothes, which try to monitor your sweat and other health parameters and other kind of stuff. Where those clothes doesn't have any screen or a touch screen to enter the username and a passwords. So here, that's what these authors got some motivation, basically an idea, where if certain user interfaces are not possible to for IoT devices, uh, then how to incorporate the authentication and authorization processes for those devices where certain user interfaces are not possible. So here, for example, a smart fabric, that's what you can, that smart fabric is nothing but a cloth where you can have some small embedded antennas and communication interfaces. That it is where it is a wearable thing and it is going to be worn by the particular person. And of course, those devices can also be interacted with the smartphones that you can interact with this. So those IoT devices, you can interact with your smartphones, but through smartphones, you can authenticate it. But that is also not the way to authenticate those IoT devices if the IoT devices are connected to your smartphones, and through smartphones you try to provide the usernames and the passwords. So this lacks of user interface gives rise to a fundamentally challenging question. So user interfaces are not possible on IoT devices, most likely for most of the applications. So the challenging question here is, how do so this is the problem is there. How do we authenticate and authorize users for the IoT where we lack conventional user interfaces? So conventional user interfaces that what we use in our day-to-day activities, like entering the username and password, such kind of user interfaces which are not possible to be deployed to be developed on the small IoT devices. Then how do we authenticate? So here, if you see, of course, one example here it is given. If you have a Apple products, so Apple products like if you have an Apple Watch, and if you have an iPhone, and if you have a, MacBook Pro, of course, these three, MacBook Pro, Apple Watch, and your iPhone, all three are Apple devices only. So what Apple has given is the authentication can be easily incorporated. If you are using those three devices, if you are using the iPhone, you can through iPhone you can authenticate an Apple Watch. It means the Apple Watch which is connecting to the iPhone. And similarly, Apple Watch and Apple's iPhone can be easily authenticated using your MacBook Pro. So now, using one device, you can authenticate the other device. That is already the Apple has taken care of this one. But still, this problem, having this particular process is a very problematic. Can anybody tell me authenticating a device from another device, like the Apple, using Apple MacBook Pro, can authenticate the Apple Watch and iPhone? Vice versa. Using any one device, you can authenticate the other devices. Uh, of course, here the user interfaces are not required on your Apple Watch. Of course, user interface are much not required on iPhone. Still, it is had, but you can still authenticate through another device. That's what Apple has taken care to. The idea is to authenticate a device using another device which is capable enough to hold the user interface. But having this particular process is very problematic. Can anybody tell me what is a problem that you are going to foresee if you are using this kind of process, authenticating a device with another device?
Security issues.
Yes, obviously that is see, all this authentication and authorization itself is a security problem. It is a security aspects. Now my question here is, okay, I'll put the question directly to the here. So if you are using a MacBook Pro, if you are using a MacBook Pro, you can also activate your iPhone. You can activate your Apple Watch, because all three are from the same manufacturer. All three has got certain security mechanisms. You can use it. But if suppose instead of you, if your friend is accessing your MacBook Pro or any other device or Apple Watch or iPhone for some reason or the other, your friend has access to that one device. When you got an access to one device, automatically your friend can access the other devices also. Is it not?
Yes, sir.
Yes. So that's why this Apple concepts of authorizing and authentication of other devices. If suppose an attacker means a friend of you, of course, when you just move out of your MacBook Pro, when you go out of your desk, and that person can come and access the other devices. Of course, that the security, it is a flaw. It is going to have a security issue here. So this kind of authentication and authorization is not acceptable for IoT devices too. So then, what are the other what are the prospective solutions here? So what are the possible solutions we can have? So here, these authors has given two different way of those things. So one is authentication on devices that maintain continuous physical contact. Continuous physical contact. It means either it can be on your body, or it can be continuously contact with you. It need not be on the body. You have to catch hold of that device continuously, so that you can authenticate the other devices. That is Is it possible to authenticate if you are going to wear a device continuously? Is it possible to have authentication if you are wearing a means you are going to keep it on your body? It can be in on your hand, or it can be on your chest, or it can be on your head, or it can be on your legs. It is a wearable device. So what this particular model is, devices that maintain contact with the user can support new forms of biometric authentication. Since the device is already in contact with the body, your biometric authentication is already been taken care. So, but how that is taken care? How that particular thing is happening here? So here, most of the devices fall into two categories. So devices of the first category either contain an inertial measurement unit. So IMU. What is IMU, please? What is an example for an IMU? Inertial measurement unit. This we have studied in the first week or second week of our discussions.
Accelerometer.
Yes, exactly. Accelerometer or your gyroscope, all those are nothing but inertial measurement units. They are measuring something. So you know what is an accelerometer is meant for? Measuring the distance that you walk, or your gyroscope gives the directions in which you are being positioned. So your accelerometer, gyroscope, your triaxial gyroscope, there are different types of gyroscopes and all. So basically, they are inertial measurement units. So basically, which is comprised of accelerometers and your gyroscopes. Or sometimes your initial measurement units are embedded into your device itself directly. And there is another devices of second category containing photoplethysmorgum, that is, we call it as PPG, photoplethysmorgum. So photoplethysmorgum is basically, it is a sensor consists of your LEDs and light sensor. Basically LEDs and light sensor. That photo means basically from the light sensor, you try to recognize some kind of phenomenon, and you try to understand that the reflections of the light. So that is basically your PPG. So basically, most people you might have seen when you go to some hospitals, or you might have seen in the movies also, there is something like ECG, echocardiograms, and PPG. So like this PPG also, the tests also going to be similar to that, where a light sensor tries to measure some kind of intensities of the light reflections, and you try to get the data and analyze those data. So these are the two things. One is using inertial measurement units, and other using your photoplethysmorgum. Basically, these are your wearable devices. So once you put these two devices, either PPG or your IMUs, into a device, and you are wearing the device continuously, then obviously that authentication of IoT devices is also done. So how it is done? Let us see here. Specifically using the IMU, we can develop authentication. That's what the author says, using the initial measurement unit, that is using your accelerometers and gyroscopes. Techniques that are based on principles that users frequently move their limbs. So whenever you move your limbs, automatically you are going to get a unique patterns. Please remember, that's what it is already scientifically proven. So you need not worry about this. But so these people using the inertial measurement units, while moving your limbs and trying to analyze your gait. Gait means your walking style. Whenever you walk, each individual has his own walking style. Please remember. So each individual can be identified by looking to the walking style also. So if you look to the walking styles, and so what they have done is, so just I will read out here a little bit. So using the IMU, we can develop an authentication technique that are used on the principles that users frequently move their limbs in unique patterns throughout the time they use the device. An example of well-known trait that differs across users is gait. If you extract the patterns of the output of the inertial measurement unit, it means if you try to get the patterns from the accelerometer and the gyroscope sensor due to the user's unique gait, and we can use simple machine learning techniques. So after you extract the patterns, you apply the machine learning techniques, and apply them continuously. So you can easily authenticate so and so user is using so and so devices. It means the users are authenticated as well as the authorized to use those resources and access those resources. So it is, but the only thing is it should be continuously wear, and it will be on the body most of the time. So if such a technique was developed and put into practice, a device of the first category worn by the user could monitor the user continuously and frequently authenticate the user's legitimacy and before allowing the users to perform appropriate options. So, for example, the same MacBook Pro, the same example. So, even if your friend, even if your attacker comes and uses the MacBook Pro, and since that if you are following the IMU's patterns and if you apply the machine learning, so and so person only can use that MacBook Pro. If anybody comes and use the MacBook Pro because that patterns does not match to your owner, definitely that cannot be accessed. The other devices cannot be accessed. So that's what they have checked it, and they have already provided those results. You can refer to those papers in the references. How that particular thing has happened. Similarly, there is another device called PPG. The sensor provides an opportunity to study the PPG signal for unique patterns. So PPG, that is what basically you are using the photoplethysmogram, that is a light sensor with LEDs. So that light sensor with LEDs, researchers have shown that due to slight variations in humans' heartbeat rhythm. So every individual has got a heartbeat rhythm. Slight variations are there, and those variations and the patterns are been collected, and those patterns will definitely identify the uniqueness of that particular person. So a person can be identified based on those particular patterns. So this is also been proved. This is enough to indicate what's unique to an individual user is. So using this ECG or that is PPG signals also, you can identify whether the right person is using the right device or not. Consequently, just by using the ECG signal, we can design user schemes to authenticate. Although several ECG schemes have been already come, but still a wide request is there, and some little bit limitations are there here because the amount of blood flow in the user's veins depends on also on the PPG signals that you retrieve it. So these using PPG and using IMU, how the authentication has been performed, that's what they have given the information here. Similarly, you can refer to authentication of devices that don't maintain permanent physical contact. So if you don't want to wear a device continuously, can anybody tell me what is the other ways? How do you authenticate a user to use a device that is IoT device basically, or IoT devices can do exchange their data for a certain users who are using those devices? How that particular things can be established? Can anybody tell me here? Without wearing a device. You have seen by wearing a device, an individual is being identified, and that uniqueness of the identity is being known by using the either IMU or PPG. Then they can, that authentication allows to use the devices, and the devices can do their rest of the work. The other way is if you don't want to wear a device, more challenging is to design an authentication scheme that can identify users for devices that don't maintain permanent contact with the users. So there is no permanent contact. It is not a wearable device. Such devices include those devices which are put in your environment, in your smart home, in a smart office, or in a smart building. So something like that, in that kind of applications, you can put certain kind of mechanisms, where those mechanisms are called as using radio frequency signals. So basically, these are pervasive modalities where using your RF signals, radio frequency signals, you can identify whether the right person is there in the home and the right person is using the devices and the right person is able to operate the devices and make use of the devices to exchange the data. So here, for any RF signal, please remember radio frequency. Even your Wi-Fi signal also you will get the channel state information. Two things are needed for your Wi-Fi signals, for your RF signals. One is your channel state information (CSI), and other is your received signal strength. So how much strength of the signal is received when you have certain interferences or when you have certain obstacles the signal is passing through, or when the signal is passing through a wall, how much signal is received on the other side of the wall, like this. So you have two different informations. One is channel state information and another is called RSSI. You can call it as a received signal strength indicator, or RSS in simple terms. So using this uh, uh, RF signals, so with what these people have done is they have used their Wi-Fi signals itself. So Wi-Fi itself is one of the RF signal. Please remember that. So in your own home, you have a system here. So what is that system is basically in your own home you have a Wi-Fi router. You have a laptop. That's all. These are the two devices they have used it, and these are put in a particular room. So I'm just explaining the case study here. Please understand. So what happens is whenever a person, an individual who is walking towards this router, of course, one individual at a time only, walking towards this router. So this Wi-Fi router, basically, you are walking towards the Wi-Fi router, and the signals that are been coming from that Wi-Fi router, those signals are being collected by the laptop. So this laptop is receiving the Wi-Fi signals. So when a person is walking towards this Wi-Fi, and each individual's walking styles are being noted down. Please remember here, each individual signals, each person's patterns obviously have been noted down here. And like this, they have done for 50 persons. So and they were able to identify whether the right person is there in that particular smart home environment or not, and the right person is using those devices or not. That authentication and authorization is also been taken care. So this type of experiment here, just how the recording of the individuals have taken place and how these things have done. If you read this paper, it will be very interesting for you. In every own home, they can do. You can also do such kind of data collection and data analysis. Also, you don't require any specific IoT devices. Of course, this case study, it also has got certain limitations. Uh, so please, once you read the conclusion and what are the things, so they have done certain 50 human subjects walking in a typical laboratory with area of 50 square meters, and that method is called as Wi-Fi U for a human being, basically. So for each human being, the gate as well as the Wi-Fi signals that are coming from the reflections of the human being, those patterns have been received, and they were able to identify the accuracies. Please see here, 79.3, 89.5, and 93% of accuracy in determining and identifying the right person who is present in the home with the right devices to be used or not. They were able to assess this. So if you please go through this and let me know, I'll ask some questions in the coming Friday session. So the paper is very interesting and it is like just a very simple paper. That's all. It's over. Almost half of the paper already I given to you. Since the time is a constraint for me, I cannot read every sentence. So, but how the authentication and authorization they have done. So they have just used. Please remember, they have used the Netgear Wi-Fi router. That's most of you might have similar Wi-Fi router will be there in your own homes. They just use the ThinkPad laptop. That's all. A laptop, again, there are no required modifications. That Wi-Fi NIC card is there for them. So that is using their laptop, and with the Wi-Fi router, they have done this experimentation. It is very interesting, and a lot of research works is also there here. For us also, we can also explore really. And of course, this is a paper published in 2017. But if you see the latest publications of this, something like if you see on the net, 2018, 2019, still people are doing a lot of works in this one for the last 2-3 years. We can also explore. There are challenges are there. We can also try and we can also contribute and we can get some outputs. So please go through the paper and let me know if you have any doubts. So here, what you need to understand from this is basically we are trying to authenticate and authorize your IoT devices without the user interfaces. Please remember, that is one very interesting thing here. So without the user interface, it means there is no login form. There is no need to enter the password. But with the human beings itself, how the things are getting evolved, authentication and authorization. Today you have the biometrics, like your what you see, your eye and as well as your thumb impressions and as well as your face recognitions. Like this, they have come out. Of course, they have done much advancements, but in future you may get it from your walking styles, your gait patterns, even your heartbeats can also be a biometric devices in future. Please remember, because those things are also having problems. Your hand thumb impressions and your eye readings and as well as the face readings, it can be also confused. Means it can be compromised too. So new authentication and authorization mechanisms are coming. Of course, it will be easy for you to understand. Simple 4 or 5 pages are there. So that's what I hope you are able to understand my points. What I'm trying to convey to you.
Yes, sir.
Yeah. Good. So please let me know if you have any queries here at this point. Those both the papers I am just uploading. Let me just upload it here, that you can. You may not be able to download the paper if you don't have the IEEE. If you can download from other sources, you can download it. If you cannot download it, you can read the paper from here. I'm uploading it, and after you read the paper, I will come back to you on Friday. So I'm just expecting some queries, of course, and as well as some people who are interested to come forward to do that similar works, not the exact the same work, but a similar work. Yeah, please let me know if you have any queries. Please let me know. Of course, what I presented is not the complete authentication and authorization processes. I have just taken one case study so that how the authentication authorization is taking place for Internet of Things. So there are various ways are there, various methods. This is one among them. Please let me know any queries are there. Those are having that problem of that connecting to the Raspberry Pi, not connection, that the node server for humidity and temperature. So I will just check the system is on or not. Then you can send me an email. Then at our mutual free time, we can connect online and we can check it. That
Sir,
is all. Yeah.
I just now I tried running it once again, sir. It worked, sir. I got the values.
Good. Good. Very good. Excellent. Just please keep trying. There is no. These are all small things and very simple things. Unless until you don't try, it will be a big confusion for you all. If you try, it will be easy only. That is for sure. That much I can tell you.
Yes,
Sir,
yes.
that LED coin will be free, so check that.
Yes, see, I will tell you today again. One meeting and afternoon class is there. By the time I reach home, it will be around 7 o'clock, 7:30. So today may not be possible. Tomorrow, either tomorrow evening. Is it okay? Tomorrow evening. After I
Okay,
go
no
home
problem.
tomorrow evening, then I have to connect because I will not. Because for that coming only 2 3 weeks, I will not bring already the system from home to office. So anyway, for another 2 3 weeks, the systems let it be there only, and let it be run so that I will not disturb you. Because sometimes some people are connecting them in the nights also. I have seen the log files. I could see on the log file, and sometimes some of them are just putting light on. That's all. Early morning they have switched off. Very interestingly. Yeah. So anyway, I'll just give the system. So tomorrow evening after I reach home, I will just please send me an email so that I can by around 7 o'clock tomorrow evening. You please send me an email. Okay, we'll connect it.
Okay, sir.
Sir, can I contact you at the same time, sir, tomorrow?
Yeah, no problem, no problem.
Okay, sir.
So, so please take care of yourself. Yeah, and yeah, any queries, let me know. Otherwise, we will wind up the session for today, and we'll meet on Friday morning. And those students who are attending the IT lab, please, I will just take today. I have a meeting from 2 to 3. If it completes by 3, I will join the session at 3. Otherwise, I will join at 3:30. And just
Yes, sir.
inform.
We received that mail. That is forwarded to all or just for the
Yeah, it
students?
was sent to all, but I am not
Okay.
sure whether everybody might have seen their emails or not. That is a problem. No? That is
Okay.
okay. Yeah. Okay. Please take care of yourself. Bye. Thank you.
Thank you, sir.